Hi everyone, welcome to our video on how do we find the surface area of a triangular prism. This is the third lesson of chapter 8. If you would like to pause the video to give the do now a try, now would be the time to do so. All right, the do now. Find the area of the triangular slice of pizza. Here we have a triangle. You may not be able to see it, but there is a right angle here. I'm going to circle it. I'm going to be referencing a right angle through the couple questions we do in this video. Just keep in mind, a right angle is 90 degrees, and it looks like this. I'm going to be pointing out where the right angle is located because the two lines or two dimensions that form a right angle in a triangle are always going to be the two dimensions that we need to find its area, the base and the height. Those are the two dimensions we need to find the area of a triangle. So I'm going to be referencing that throughout this video. The formula for area of a triangle is 1/2 base times height. And we're going to substitute into our formula. 1/2, the base of this triangle is 5 inches, times the height, which is 7. And yeah, obviously these are the only two dimensions in this particular triangle, but those two dimensions that we're using are the ones that form that T, or that right angle that I circled, 5 and 7. Now I'm going to use my calculator to figure out the answer to this. We have 1/2 times 5 times 7, which gives me 17 and a half. I'm going to write it as a decimal, 17.5 inches squared, because we have square area. Very nice. We're not going to watch or go to this investigation link. I'm just going to talk about this diagram here. As you can see, we have one of our nets here. And the strategy that we're going to use to find the surface area of this figure is to find the area of the two triangles and 3 rectangles and add the 5 areas together. Keep in mind what a surface area is. It's the total amount of space that surrounds a three-dimensional object. Think of it as wrapping up an object. So how much area does it take to cover that surface? So if I were to take a triangular prism and unfold it, it would result in a net that looks like this: 2 triangles and 3 rectangles. So if I find the area of each of the 2 triangles plus the 3 rectangles and add all 5 of those shapes together, I will get my total surface area. So our notes for the surface area of a triangular prism consists of the following. We have our net drawn. Draw a net like in our example above. Find the area of each triangle and each rectangle. Sorry, these spaces are so small. And then we are going to add all the areas together to find the surface area. Basically what I explained above. Now, triangular prisms come in 3 different shapes and sizes, and here are the nets of each of those 3 options. The first one is when the triangular prism has 3 congruent faces. So 2 triangles followed by 3 rectangles or squares that are all the same area. So each of these faces are going to be the same. We have triangular prisms that have 2 congruent faces. So 2 of the rectangles may have the same dimension and 1 has a unique dimension, followed by our 2 triangles. Or we could have a triangular prism that has no congruent faces. So all 3 rectangles are different dimensions, and we have our 2 triangular faces. I'm about to do 3 examples for you that satisfy each of these 3 different instances. So if my explanation for these 3 different types of nets of the triangular prisms confused you, hopefully it makes a little more sense when I go ahead and do some examples. All right, let's go to the next page. All right, we're going to try number 1 together. So I'd like you to also follow along with me and use the strategies that I do in order to find the surface area of each of these triangular prisms. I have a highlighter handy because I'm going to use it to highlight the triangle in each of these diagrams. So if you want to go grab a highlighter, I would suggest it. It definitely makes things a little bit clearer for you. So here we have a triangular prism. It's not clear in the diagram, and I know I tell you to never assume anything in a diagram, but we are going to, and I'm going to tell you that this triangular face here is an equilateral triangle. Each of the sides is the same measure. So we know what those tick marks look like, so I'm going to draw them in. Tick mark, tick mark, tick mark. So we can assume that each side of this triangle is 2 3/5 of a yard, because a tick mark means if this side is 2 3/5, so is this one with a single tick mark and this one with a single tick mark. For reference, I am going to highlight this triangular face. It's going to be helpful to complete this question. Okay, so the first thing that we are going to do is find the area of the triangular face. And just like we did in the previous lessons, I'm going to be very organized as I'm finding the area of each of my faces in the corresponding boxes. So I'm first going to find the area of my triangular face. So I'm going to label that first box triangle. We know the area of a triangle is 1/2 base times height. And like I said in the do now, I would like you to circle your right angle, which is right here in my diagram. The reason why I'm circling my right angle is because that tells me which 2 dimensions I'm going to be using to find the area of the triangle. So the 2 dimensions that form this right angle, that make this T, if you will, are the base of 2 3/5 and the height of 3. Once again, the 2 dimensions that form this right angle are the base of 2 3/5, which I'm putting into my formula, and the height of 3, which I'm also putting into my formula. So when I use my calculator, the area of this triangle is 1/2 times 2 3/5 times 3 to get me an area of 3 9/10 yards squared. Now, the opposite triangular face, which if you can imagine is on the other side of this 3D figure, has the same exact area as the front face. So same area of the triangle that we just did right here. So that area equals 3 9/10 yards squared. Okay, now we are going to need to find the area of each of my rectangular faces. Remember, if we unfold this 3D prism, it is going to have not 1, not 2, imagine the bottom face, and 3, the 3 rectangular faces. So I'm going to write each of these down: the right rectangular face, the left rectangular face, and the bottom rectangular face. Now there is a good strategy that I would like you to use when completing and figuring out the areas of these rectangular faces. What I would like you to do is you're going to multiply each side of that triangle that you highlighted by the height of the prism. We can tell that the height of this prism is 5 2/3. In other words, this is a dimension that was not located on the triangle. Was not located on the triangle. So if you can identify what the faces of that highlighted triangle are, In this case, example number 1, each of these faces is 2 3/5. For each of my rectangular faces, I'm going to be multiplying 2 3/5 by 5 2/3. So I'm going to find my first one for you. Area equals length times width. This is a rectangular face. So once again, where I find these two dimensions, for the first rectangle, pick a side length of your highlighted triangle, 2 3/5. In this case, that's the only dimension I use for my triangle. Do not mistake 3 as one of the sides of the triangle. That's the height. What I'm saying here is you're picking one of the sides of the highlighted triangle. And once again, in this special case, each side is 2 3/5. So when I do this 3 times, each of these is going to be 2 3/5 multiplied by that other dimension that's not on the triangle. This is the height, or it's going to be the width of the rectangle we're talking about in this case. 5 2/3. Sorry, I was writing it on this one first. 5 2/3. And 5 2/3. Now, yes, I understand that it's redundant to be doing this 3 times, and usually we just write same rectangle, but I'm just showing you what it looks like here. So I'm only going to do this once because it's the same dimensions 3 times. 2 3/5 times 5 2/3, and I get an area of 14 11/15 yards squared, which is going to be the same 3 times. Okay. Now the surface area is going to be adding all of these areas together. So 3 9/10 plus 3 9/10 plus 14 11/15 plus 14 11/15 plus 14 11/15. Let me add all those up on my calculator. 3 9/10 plus 3 9/10 plus 14 11/15 plus 14 11/15 plus 14 11/15. We get a total surface area of 52 square yards. That is my total surface area. Now, before you try, I'm actually going to do an extra question before the now you try. Please make sure if my explanation of where I got these dimensions from confused you, this one's going to be a little bit different, but please just pay close attention to how I explain where I get my dimensions from when I'm finding my areas for the nets. All right, we're going to find the surface area of this extra question, so please just watch carefully as I figure out the surface area of this 3-dimensional triangular prism. I'm first going to do my triangle. And my suggestion to you is to highlight that triangle. Highlight that triangular face. And let's circle our right angle. So to find the area of my triangle, which is 1/2 base times height, the reason why I've circled my right angle is because it tells me which 2 dimensions I'm going to use in the area of a triangle formula. 1/2, which 2 dimensions make this right angle? Well, 12 and 16. So when I use those 2 dimensions, 1/2 times 12 times 16, I'm going to get my area of 96 centimeters squared. Now, the triangular face that is opposite this one, right over here, is going to be the same triangular area as over here. So I don't need to do that again. All right, time for my rectangles. So this is really important. The strategy that I described in the earlier example is this. You are going to identify the 3 sides of the triangle that you highlighted. In the example here, 16 is labeled, 12 is labeled, and my last side of this triangle that I highlighted is here. What is that amount? Well, it's 20, because opposite sides in this prism and in prisms in general are equal or congruent. So if this is 20, so is this dimension. I'm going to write it in, 20. There are my 3 faces. Sorry, my 3 dimensions of my triangle, 12, 16, and 20. So when I'm finding my 3 separate rectangular areas, these are going to be the 3 different values that I use. Let's start with the bottom. The bottom rectangle. Formula for area of a rectangle is base times height. Length times width. So I'm going to pick one side from my triangle. Let's start with 12 because that coincides with the bottom rectangle that I'm doing here. 12, I can even put a little check mark so I know I took care of it, times the height or the width of this prism and the width of that bottom rectangle, which is here, 10. That number, the width, is going to be the same each time I do these areas of these 3 rectangles. Area equals, mental math, this is 120 centimeters squared. I'm going to do my right facing rectangle. Area equals length times width. Once again, here we go. I'm going to pick another side of my highlighted triangle. This time I'll pick 20 times, once again, that same width that I picked last time, 10. Because if you can visualize it, now we're talking about this face, which is 20 times 10. 20 times 10 is 200 square centimeters. And my left rectangle area. Area equals length times width. Area equals. So the only other triangular side dimension I did not use is 16 times that same width that we used every other time, which is 10. If you want to visualize it, here's that rectangle, which is 16 by this amount is also 10 because it's the same as this one. And 16 times 10 is 160 square centimeters. If I wanted to find the surface area of this figure, it'd be 96 plus 96 again, plus 120, plus 200, plus 160, which is a total surface area of 672 square centimeters. All right, time for you to try. If you'd like to try to find the surface area of this triangular prism, feel free to do so. I'm going to go over the answer now. All right, you should have those highlighters. You should have your triangle highlighted and your right angle circled. And if you had trouble with this one, I know once again we say not to ever assume anything, and nothing's really being assumed here other than, and we know this, that if you wanted to fill in these dimensions, 4 millimeters and 4 millimeters, those are the other 2 dimensions of this triangle because opposite sides are congruent or equal. So if this is 4 millimeters, so is this. This is 4 millimeters, so is this. All right, I'm first going to find my area of my triangular face. Area equals 1/2 base times height. Remember, the dimensions that make the right angle are the ones that I'm going to use in the area of my triangle. So the two sides that form this right angle are 4 and 4. You should not be using 5.7 in this formula. 1/2 times, once again, the two sides that make the right angle, that make that T. 4 times 4. Area equals, you can use mental math here, 1/2 of 4 is 2, and 2 times 4 is 8 millimeters squared. My other side, which is also a triangle, is going to be the same triangle area as here, which is going to be an area of 8 millimeters squared. Time for my 3 rectangular faces. So I'm going to start with I start with the right face, this one here. As you can see, this is one of those instances, we went over it in the notes, where we have 2 congruent faces here. This right face is going to be the same as this left face. So I'm only going to have to do, I'm going to have less to do here. Area equals, we're doing rectangles now, length times width. The area equals, so the strategy here, once again, we're going to pick the dimension of my highlighted triangle. Let's start with 4. We're going to multiply by that other dimension that's not on the triangle. In this case, it's 3. And this makes sense because I'm finding the area of this rectangular face, which is a 4 by 3 rectangle. 4 times 3 is 12 square millimeters. My left face, this one, another 4 by 3 millimeter rectangle, is the same area as this rectangle to the left. So we have another 12 square millimeter rectangle. My last one, the back rectangle, if you will, the one that's back here. Area equals length times width. The only triangular dimension we haven't used yet is the 5.7 multiplied by that same height of this prism, the same width we use every single time. And 5.7 times 3, 17.1 square millimeters. And now putting it all together, our total surface area is going to be 8 plus 8 plus 12 plus 12 plus 17.1, which gives me a total of 8 plus 8 plus 12 plus 12 plus 17.1, a total of 57.1 square millimeters. That is my surface area. Very nice job. Just to summarize this all, which of the following nets represents a triangular prism? It's going to be this one, because a triangular prism, a triangular prism has 2 triangles and 3 rectangles. 3 rectangles, 1, 2, 3, 2 triangles. There should be 5 total faces. That's why we've been doing questions with 5 boxes for our work. This net has 1, 2, 3, 4, 5, 6 faces. That does not make any sense. Alrighty, everyone. Very good job. Thank you for watching the video. Please make sure you reach out to your teachers if you have any questions at all on how to solve these questions. Please take your time when you're solving your quizzes or your CASEL Learning questions and reference this video if you need more help. Have a great day. Bye.